This video is on dehydrohalogenation. Dehydrohalogenation is the elimination of a hydrogen halide to form an alkene. We should approach this by trying to aim for an E2 reaction, as there's not that much competing product. Remember, E1 occurs with SN1. So what do we need for an E2 reaction to be successful? Well, we need a strong, bulky base. And we want to take advantage of the Zaitsev rule when we are trying to figure out our starting material or product, depending on what we're looking at. So for example, in this case, we have these starting materials. What will our product be? You may pause now. And here is the answer. Let's do another one. What is the product of this reaction? You may pause now. And here is the answer. Notice that we have conjugation. Therefore, this is the major product. So say you want to form this product. Which one of these two starting materials would be better if we were using the conditions of potassium hydroxide and water with a lot of heat? Justify your answer. You may pause now. And here's the answer. Notice that you need to have a halogen terminal to be able to form a terminal double bond. Otherwise, Zaitsev rule will define the product. We can take advantage of dehydrohalogenation to even prepare alkynes. It's just the same as with alkenes, but we happen to need to do it twice. So in other words, we need two leaving groups. We need two halogens, and these halogens may be either geminal or vicinal. Geminal is when they are both on the same carbon, and vicinal are when they are on neighboring carbons. How does it work? Well, here we go. If we add 2 potassium hydroxides in ethanol and heat this dibromo-stilbene, we will eliminate both halogens to yield this triple bond. Pretty neat, huh? Here's an example of a geminal dibromide reacting with 3 equivalents of sodium amide in ammonia. Now, why do we need 3 equivalents? Well, because after every deprotonation, we are making a more acidic proton, which means that as our product is more reactive than our starting material, we are going to use up the base no matter what. That means that we have to have at least 3 equivalents of the base to be able to form all product at the highest possible yield. If we want the protonated alkyne, we are going to have to work it up with an acid. Of course, we don't have to start with a dihalogen. We can also start with a ready-made vinyl halide, as it's just one step away. At this point, 1 dehydrohalogenation will give us our final product. Now you have a go. What would be the products of the following reactions? You may pause now. And here are the answers.